what I'm going to show you now is one strategy that we can use to factorise quadratic trinomials when our a value is equal to 1. Now, what do I mean by that? Well, if we were to sort of state a quadratic trinomial in general sort of form, we would say that we would have a x squared plus bx plus c. And I'm going to show you a strategy that we can use to factorise this and put it into its linear factors when this a value here is equal to 1. And it's not always equal to 1, but that's what we're going to focus on today. Now the method I'm going to use in this is what's known as the sum and product method, where we're looking for the sum and the product of two numbers that will equal specific values. But to show you that, let's take a problem. Let's have a look at, say, x squared plus, say, 7x plus 12. Now we can see in this trinomial that we've got here that the a value, the pronumeral to our x squared, is equal to 1. So we can use the sum and product method here. And what we're actually looking to do is we're looking for two numbers that when we take the sum of them or add them together, they'll equal what our b value is. In this problem, it's positive 7. And we're looking for the same two numbers that when we multiply them together or take the product of them, they'll equal our constant value or our c value, which in this problem is 12. Now, when I'm looking at this, I always start with this product value of 12, and I start thinking of factors of 12. So if we start listing them out, we've got factors of 12, so we've got 12 and 1. Now if we add 12 and 1 together, it'll equal 13, which is not the sum that we're looking for. So that's not the pair that we're after. The next factor pair that I can think of would be 6 and 2, which when we add 6 and 2 together equals 8, so it's still not the factor pair that I'm looking for. So another factor pair might be 4 and 3. Now we can see here that when we add 4 and 3 together, it does equal our sum of 7. So this is the factor pair that we're after. And what we do with this factor pair is we put it inside of our brackets as two separate terms. So when we're factorising this, we're looking to put it into our brackets where we've got an x as our first term because we're creating this x squared on each of our brackets. And we take each of our numbers here that we've found and we put it as the second term in each bracket. So it doesn't matter which way you put it. So I'll put the 4 in the first one, it's plus 4 because it's a positive 4. And the second one, it'll be plus 3. Now the advantage to all this is we can always check to see whether we're right. So if I did a check over here, what I should be able to do is take this, this factorised form of what I've just done here. So this x plus 4 and the x plus 3. And I should be able to use FOIL and multiply this out and see whether it comes back to the expanded form that I began with. So as I use FOIL will be this x times the x, which will be x squared. It will be x times the 3, which will be plus 3x. It'll be 4 times the x, which will be plus 4x. And then our last, it'll be 4 times the 3, which will be plus 12. Now from here, we'd have to simplify it by collecting like terms. So there's no other term here that has x squared, so it will still be x squared. These two here are like terms because they've both got the x. So we've got 7 of them, so plus 7x. And then the constant at the end of plus 12. And what you can now see is when we expand these brackets out, we arrive back to the same thing that we had to begin with, which means that we've factorised this correctly. Now let's take a look at another example. Let's say I had x squared, I added 3x, and I subtracted 10. Well, what we're looking at here is we're looking to find when we've got a sum, so a pronumeral of x for our sum, which is positive 3 here. So we're looking for a sum of positive 3. But this time we're looking for a product that's negative, so our constant term is negative 10. Now when I do this, I'm immediately starting to think think of combinations that would work for this. So when I've got a product of -10, for two numbers to multiply together to equal a negative, one has to be positive and one has to be negative. So I know that to be the case. But I also look at the sum, and my sum overall is positive. So when I'm adding these two numbers together, one being positive, one being negative, it overall becomes positive. So that means of my two numbers, the larger of them has to be positive. And that'll help me when I'm sort of identifying my combinations of my factors of 10. So let's start working through that now. So my factors of 10, well, 10 and 1. Now I know that my larger number would have to be the positive, so positive 10, subtract 1 in this case, because we're adding -1. Now that would equal 9, so that doesn't get my sum that I'm after, so that pair doesn't work. My next factor pair, well, 5 and 2. Now if I had positive 5 and -2, let's just indicate these negatives here, so we know that we're looking at -2. When I've got positive 5, add -2, that'll become 3. So what I've got here is my combination that works. And what I do with this combination is I open up my brackets and I put my first term here, so this will be a +5. And my second one, it'll be x, and because it's negative, I need to subtract 2. So when I factorise this, I'm posing that x squared plus 3x, take 10, will factorise into the two linear factors of x plus 5 and x take 2. But we can check that. We can check it by expanding it back out using FOIL. So if I expanded this out, let's just rewrite it. My x plus 5, all in brackets, and my x take 2, all in brackets. I'll multiply my first together, so my x with my x, which will create x squared. I'll multiply my outers, so my x times my -2, which will be -2x. I'll multiply my inners, which is 5 multiplied by x, which is plus 5x. And then I'll multiply my last, so that'll be 5 multiplied by -2, which will be -10. And now I'll need to collect like terms. So x squared is the only like term of that one. These two are like terms, so I've got -2 plus 5 will be positive 3, so plus 3x, and then my constant at the end, which will be subtract 10. And what you can see here is I've arrived back, when I expand it back out, to my expanded form that I started with. So it means that this factorisation has been done correctly. Now it's important to note here that when we're using the sum product, this sort of strategy really works when our a value is equal to 1. We have to start thinking of different strategies when the a value isn't equal to 1. So it's really important to note that. But when we have got a situation where the a is equal to 1, we can think of two numbers that when they add together, they'll equal our b term, which is the pronumeral of x. And when they multiply together or take the product of them, they'll equal our constant term, or our c value at the end here. And what we do with those two numbers when we've found it is we put it back into the brackets as our second term in the brackets.